Ini sepertinya kita waktunya update peserta ya, Pak ya?
Iya, bisa di admit kayaknya.
Hai, Assalamualaikum.
Halo, Waalaikumsalam, Dr. Nursila. How are you?
I'm good, thank you. How are you guys?
Alhamdulillah, Dr. Sila.
Alhamdulillah.
Dr. Sila, actually, I am a good friend of Dr. Mahira and Dr. Nazmi.
I see. What a small world, right?
I graduated from Kyoto University, so I know Dr. Mahira.
All right.
So I will be the moderator today.
All right.
And actually, my field of study may be almost similar to you. Maybe post-harvest technology, instrumentation.
Like Dr. Mahira, right?
Yeah.
Thank you, Dr. Mahira.
Oke. Pak Iqbal ini sudah dimulai ya?
Daniel sudah bisa join, Pak?
Iya, Daniel sudah. Mana ya Daniel ya? Belum. Mana ya Daniel ya? Nah, itu Daniel sudah join. Sudah join ya? Halo,
Assalamualaikum, Pak Daniel.
Pak Daniel
ini.
Assalamualaikum Pak. Waalaikumsalam.
Mas wanted.
Masuk wanted ya. Waalaikumsalam wabarakatuh.
Assalamualaikum Pak Bambang
Assalamualaikum
Susilo.
Pak Bambang.
Waalaikumsalam wabarakatuh.
Waalaikumsalam.
Okay, I think we can start.
Okay, Andika.
Please.
Probably we can start.
Maybe Mbak Santi, YouTube streaming.
Dr. Dimas, I think Dr. Mahira is here too.
Oh yeah.
Makcik di mana Makcik?
Aceh, Daniel sang also. Daniel. Dr. Daniel also know Dr. Mahira.
Hello,
Hey, reunion with Dr. Mahira.
yeah. Doctor. Usually in the lab we call her Makcik.
Tak glamour Daniel.
Apa?
Okay.
Gelap.
Kak
Okay.
Mahira, mana videonya Kak Mahira?
Bila mau datang UPM, boleh jumpa Dr. Mahira?
Soon. Okay, Andika, we can start now.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. I'll be the host for this webinar. My name is Andika, student of Biosystems Engineering Department, Universitas Brawijaya. I will guide you during this event in the first webinar series of Smart Innovation and Future Development in Biosystems Engineering 2022, which bring topic Role of Future Agricultural Technology to Sustain Society Welfare. And also, I'd like to announce that now we have more than 100 participants from students, lecturer of Biosystems Engineering Department, and also from other institutions in our Zoom meeting. First of all, I'd like to say thanks to God who always give us guidance, healthiness, and happiness so that we could gather in this Zoom meeting to participate in this special occasion. The Honorable Professor Imam Santoso as the Dean of the Faculty of Agricultural Technology, the Honorable to the Speaker, Dr. Nurhasila Hashim, Mr. Anton Fraudiro M, and Dr. Daniel Fakturahman, and also for all the participants who have joined in this webinar. Before we go into the main event, I'd like to remind to all participants to obey the housekeeping rules. Firstly, all participants required to rename the Zoom name with the format name of institution _name. The second, during the guest lecture, the participants should turn off the microphone and activate the camera. Then, during the Q&A session, all participants are allowed to unmute the microphone and deliver a question directly to the speaker. Or you can deliver via chat Zoom. Attendance form will be given during the guest lecture by the committee. So make sure that all of you fill the form to get the certificate. Moving on, I would like to explain the rundown of this event. First, there will be the opening. Then second will be the opening and welcoming speech from the Dean of the Faculty of Agricultural Technology by Professor Imam Santoso. And then will be the main session where the guest lecture given by our speakers, and then followed by discussion session, and then the last will be closing. Ladies and gentlemen, we are now going to listen to the opening and welcoming speech delivered by the Dean of the Faculty of Agricultural Technology. To Professor Imam Santoso, the time is yours.
Thank you very much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. The Honorable Associate Professor Dr. Nurhasila Hashim, Head of Department Political and Agricultural Engineering UPM, the Honorable Anton Paliro, MSc, Chocolate Research in Japanese Private Company, and the Excellencies, Dr. Daniel Fakturahman, MSc, CEO and co-founder at Frescan Technology, PC Greece, Vice Dean, Head of Department of our participant. On behalf of Faculty of Agricultural Technology, Universitas Brawijaya, it is my great honor to welcome you to the Faculty of Agricultural Technology webinar series. First, I would like to say thanks to our God, Allah Subhanahu wa Ta'ala, Alhamdulillahi Rabbil Alamin, that give us opportunity and healthy to give opportunity to conduct and to join with this webinar, because we know that our institution, faculty, and university have program to increase the international level. So, international webinar series is part of our effort to support this program. And second, I would like to say thank to some speakers here, especially Associate Professor Dr. Nur Hasil Hashim. Thank you for your time. Become speaker in our webinar, and also Anton Prawiro and Dr. Daniel. This webinar, in our perspective, is very essential to support our program, especially FTP, Faculty of Agricultural Technology, Universitas Brawijaya, to become as one of the center of excellence related with agricultural engineering, food technology, biotechnology, agri-industrial engineering, and environmental engineering. So this topic is very interesting and closely related with our faculty, especially related with for harvest technology in Department of Agricultural Engineering and Biosystems. This webinar also is one of our effort to collaborate with many parties, domestic or international. Now, various local international collaboration have been made, and several of these followed with some program like joint program, education and training, research, communication, and services, and joint publication, of course. Several activities have also been initiated with industry or private sector, leading to collaborative research and application of several product prototype, mission development, and even industrial prototype. So many activities we can create with international partnership. In that context, I believe that collaboration with many partners, especially outside and overseas parties, play an essential role to support FTP become international institution. I hope you all have a productive webinar here, especially all our participants can get the knowledge and experience from the expert that become international webinar expertise. And I am looking forward to the future action generated from this event, especially in international activities to support our institution to become international level. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much for Professor Imad Santoso for the speech. Before we start our main agenda, we will have the photo session first. So I'd like to all ask the participants to make sure your camera is on. And also for the participants who haven't turned on the camera, we kindly ask you to turn on your camera and also make sure to use the background given by the committee before. Prepare your best camera position and hold a smile for a moment. And I will have to count to 3 and we all can say cheese. Okay, everyone can get ready. Okay, I think it's ready. Okay. Now, we can start now, okay? And I will count to 3. 1, 2, 3, cheese. Okay. Okay, I think it would be nice if we get another picture. So I will count to another 3. Okay. 1, 2, 3, cheese. Okay, I think it's enough. Is it enough? Okay, I think it's enough. Okay, thank you so much for all the participants. Okay, moving on, we're going to the main session. Before that, I would like to introduce the moderator of our lecture, Dr. Dimas Firmanda Alriza. Pak Dimas Firmanda Alriza is a lecturer in Biosystems Engineering Department, Universitas Brawijaya. So, without any further ado, I'd like to give a warm welcome to Dr. Dimas Firmanda Alriza. To Pak Dimas, the time is yours.
Okay, thank you, Andika, for introducing me. Hello, everyone. I'm really glad to see all of you joining today's event. I am Dimas. I will be your moderator today. Today's webinar is the first event of the webinar series in commemoration of the 24th anniversary of Faculty of Agricultural Technology, Universitas Brawijaya. We will have three topics from three speakers. They have already joining us. They are from Malaysia, Japan, and Italy. I will introduce to you later. So today's agenda, I will share my screen. So the agenda today will be we will have three topics. First is precision agriculture in post-harvest technology by Dr. Nur Hasila Hashim from UPM Malaysia. Second topic will be chocolate innovation and market trends in Japan, will be delivered by Mr. Anton Prawiro from Fuji Oil Company, Japan. And the third topic will be business opportunity based on post-harvest technology, that will be delivered by Dr. Daniel Fathur Rahman, Frescon, Greece. And after that, we will have discussion, question and answer. So each speaker will have 30 minutes of presentation time, and then we will have discussion and question and answer later. For the first speaker, I would like to introduce you to Dr. Nur Hasila, Associate Professor Dr. Nur Hasila Hashim. Hello, Dr. Hasila. Could you hear my voice clearly?
Yeah, sure. It's
Okay.
clear.
Okay. Dr. Sheila got his PhD from UPM in 2013. She is currently head of department at the Department of Biological and Agricultural Engineering, Faculty of Engineering, University Putra, Malaysia. His research interest includes post-harvest engineering, agricultural process engineering, and precision agriculture. So without further ado, please, Dr. Sheila, you could start your presentation.
All right, thank you, Dr. Dimas. Thank you for the introductions too. All right, I will share my screen first. Okay, so I hope everyone can see my slides here. So my name is Nur Hasila Hashim. I'm from University Putra, Malaysia. First of all, I would like to say thank you to Brawijaya University for inviting me today to be part of this event. I'm honored actually to present my favorite topics, precision agriculture in post-harvest technology. Before we go further, I would like to show you this short video clip. All right, so I hope you enjoyed the short video clip. This is one of my favorite video clip in YouTube beside mukbang. Okay, all right. You can go to this link if you want to see further. I mean, the details of this Green State TV about modern agriculture. So I love this video clip because it's concisely describe how modern agriculture is very important nowadays. It's highlight the issues that are related to it, especially about the increment of human population in 2050, of which about 9 billion is it, based on the projections, about 9 billion human population will be in 2050, and then at the same time we need to produce enough food to cater the increment of the human populations, and moreover at the same time we also need to conserve the environment. So modern agriculture or precision agriculture is one of the solutions to maximize the food production. And then, sorry, it's not working. Okay. Okay, we go to the agriculture revolutions. So based on the revolution of agriculture engineering, agriculture industry evolved, okay, from agriculture revolution 1.0 until nowadays agriculture revolution 4.0, and now people start looking forward to agriculture revolution 5.0. And then it started with in agriculture revolution 1.0, of which farmers, not really farmers, people at that time use hunting and gathering methods. It's a transition of those methods to planting and sustaining, and then it was in 18th century, and then in agriculture revolution 2.0, it's transformation to the usage of mechanization in agriculture to assist the agriculture activities, and in 1960s agriculture revolution 3.0 started. At that time, automation being introduced and GIS being used in the farming activities. And now we are in the agriculture revolution 4.0. We call it as age of smart agriculture, which is featured by artificial intelligence, Internet of Things, and so on. So you can see here how the technology advancement occurred, and then significant changes you can see from agriculture 1.0 revolution until today. And then let's see what is precision agriculture. Precision agriculture is a management strategies that gathers, processes, and analyzes data, okay, temporal, spatial, and individual data to support management decision. Okay, and then this is a generic precision agriculture cycle, from planning to management, and then evaluation and observation, technology and data acquisition, and knowledge extraction. And then what about post-harvest technology? Post-harvest technology is interdisciplinary science and technique applied to agriculture produce after harvest. This includes the operations, all operations in post-harvest handling, such as cleaning, sorting, until packaging, and marketing. And then let's see a comparison between conventional method and precision agriculture approaches. Why we need these precision agriculture approaches? So you know that conventional method, most of them are non-automated system. When it is non-automated system, of course, it's time-consuming because it uses manual approaches, which relies on human labor, and then it mostly subjective and disruptive, which later on resulted to unreliable data, and then misinterpretation of assessment, and many other effects such as like it also contributes to the high cost of production due to the slow productivity. And then through a precision agriculture approach, it offers objective assessment, which is promote to reliable evaluation, and then it reduce dependent on human labor. And usually it non-destructive, so no damage on the product, which promote repeatability, and this later on will increase the accuracy. And of course, since it's automated, it is rapid assessment. And then let's see precision agriculture in post-harvest technology. There are many available sensors actually, but today we would like to discuss about these six techniques. Okay, first one, imaging-based techniques, spectroscopy-based techniques, electronic nose, electronic tongue, dilatory, and acoustic. And then these techniques being integrated with machine learning. So machine learning is actually data analytic techniques that mimics human brains. Okay, so human brains, the drawbacks of using human brains, such as consciousness, and then our physical emotion and so on, can be reduced. So by using this machine learning, we can get the data objectively, rapidly, and most of all accurately. Okay, some of the components that maybe you are familiar with, artificial intelligence, deep learning, and then other algorithms that can be used to support your decision-making process. So basically, machine learning is just a replacement of, instead of using human brains to come up with the decision-making, but this time we use a computerized system to come up with effective decision-making. All right. Okay, now let's discuss what is imaging-based techniques. So generally, it is an engineering technology combining with mechanics, electromagnetic sensing, optical instrumentation, as well as artificial intelligence and image processing technology, which offers flexibility in application. It's actually a substitute human visual decision-making process. So instead of we use human eyes to do the assessment, but this time we use a camera, a sensor, to do that decision-making process. Okay, so it's related to the functions of light. No, not the functions, but actually it's very close related to the characteristic of light. Okay, because the visual capability depends on the light perceived by the human eyes, or in this case for humans, light perceived by our eyes, and for sensors, it based on how the sensors can perceive the light. All right. So we know that when light hits a surface, a sample, it will be reflected, absorbed, or transmitted. So this process is actually carries useful information that we can manipulate, to do assessment, to evaluate fresh produce quality. And then moreover, electromagnetic spectrum, it varies from ultraviolet to infrared. So there is a small wavelength, right? Okay, from ultraviolet to infrared. So each wavelength carries like a kind of a thumbprint. Okay, each thumbprint is related to specific properties around the world. All right. In this case, I want to highlight, for example, fresh produce in agriculture. Wavelength at 450 nanometer is closely related to carotenoid content, and then at 650 nanometer is closely related to the chlorophyll content. So this characteristic, this properties relationship, we can manipulate to identify, to come up with innovative strategies as a sensing instrument for agriculture produce. The fundamental equipment for imaging-based techniques is, of course, a sensor. In this case, for imaging, camera. Okay, and then light source, and a computer, okay, for data processing. This is a workflow, okay, for the system. First is image acquisition. This is the input raw data. Okay, for example, fruits, many types of fruits, any fruits. Okay, and then we do image processing using a computer. Okay, to extract features that may be related to the properties of the fruits. Okay, and then we use machine learning to analyze the data, and lastly come up with the decision making. Okay, quality evaluation. And then there are many optical imaging techniques available. Okay, one of the familiar one is RGB imaging. Okay, you know RGB. You always use this RGB imaging system, especially on your phone. Okay, so we are very familiar with this one, RGB imaging, and then we have hyperspectral imaging and multispectral imaging. The difference between these two is just in terms of its wavelength, of which multispectral is lesser than hyperspectral. And then backscattering imaging, of which we use a single light source, okay, very intense light source, and then we analyze its scattered image and then relate with the fresh produce properties. Next is thermal imaging, which measures the temperature pattern of the samples. Fluorescence imaging, as reflected by the name, it study the fluorescent properties. And then magnetic resonance imaging, which is based on the interaction of a certain nuclei with electromagnetic radiation. And lastly, ultrasonic imaging, which is based on the sound waves of the samples and the assignment of the sensor. All right. So there are many actually. This is some of the sensors that techniques that we are familiar with. And then you can see from the table here the applications of imaging-based technologies for food quality evaluations are very wide, okay, around the world. Okay, you can see here it has been tested in many fresh produce, for example, soybean, watermelon, even rice, and then peach, tomato. The list goes on until here. Okay, there are many, and then all the results shows a very promising results, and it is proven can be used to detect those quality parameters that stated here, for example, defect, water content, and then maturity level, moisture content, and so on. Okay, this one is, this picture shows example of hyperspectral imaging that being used to detect the quality of citrus. The system is similar to the basic component as imaging-based techniques, which is consists of a camera and then lighting system, and then here it's being installed in the sorting line. Okay, you can see here how it's planned to be installed too in the sorting line. Okay, we put the camera here. Okay, and then the fresh produce will go through this line. The camera will capture the images of the sample stored in the computer, and then computer will directly analyze the image and segregator here. Okay, based on the decision making made by the machine learning that analyzed by the computer, the samples will be then classified into bad and good samples. Okay, compared to the this is automatic. It can be conducted automatically without using assistance from human labor, which we know that it may promote to many drawbacks. And besides that, it's manually handling. And then let's discuss about spectroscopy-based technique. It is basically similar like imaging-based techniques. It is about interaction of electromagnetic spectra. Okay, and then assisted with chemometric analysis. I think the most familiar spectroscopy-based techniques are visible to me: NIR spectroscopy, and then NIR spectroscopy, and lastly Raman spectroscopy. And then this is the basic instrumentation for spectroscopy-based techniques. Basically, the system consists of a light source, and light source could be as simple as light bulb, okay, and then monochromator to break the polychromatic radiation into component wavelength, and then sample chamber, and then detector to convert electromagnetic signal quantitatively into a voltage or current level, and then a computer for data analysis. And then you can see here it has been widely applied in many agricultural produce and proven to could be useful to detect bruise, defect, and then maturity level, pathogen, the presence of pathogens, adulteration, and many more. Besides fresh produce, it also has been tested to chicken breast as well as beef cuts. And these pictures shows some of the examples how portable spectrophotometer being applied to detect disease in leaf, and then maturity level in fresh produce, okay, as well as it's also possible to be used to detect the nutrient content in the soil as well as moisture content. And then other non-destructive approaches includes e-nose. Okay, e-nose is electronic nose, which is mimic the function of human nose. Okay, so you can see here, this is the comparison between human nose and electronic nose. So for example here, you want to identify which variety of apple is this. Okay, so by using our nose, we just smell, okay, try to identify the smell of this apple, and then we use our brain to interpret, to analyze, and then come up with our decision. Okay, in this case, we use sensor array, okay, to identify the gas odor, and then we use a data processor, could be machine learning, could be other AI, deep learning, and so on. And lastly, come up with our results, classification, probability, or prediction. All right. In this case, to identify the varieties could be classification. And then other example is identifications of contaminated sapota. In Malay, we call it ciku. Okay, I don't know in other language, but in Malaysia we call it ciku, okay, in English sapota. All right, so to discriminate contaminated sapota, all right, from half contaminated and then completely contaminated, as well as fresh sapota. So by using gas sensor, okay, and then follow up with data processor, and then we can come up with the segregation result. Next is e-tongue, okay, similar like e-nose, okay. These techniques imitate the functions of tongue, okay, instead of using tongue, a human tongue. So we use sensor array to analyze the complex liquid, and then instead of using brain for data processing, so we use chemometric tools or any data processor, and we come up with the decision results. Okay, so e-tongues have been proven to be a promising tool for the analysis of many complex phenolic compounds. So it has been applied not only in agriculture, but also in biomedical, in safety, as well as pharmaceuticals. And this is the basic components of e-tongue, which is sensors, and then data processor. And this is the comparison between e-tongue and e-nose. They are basically the same thing, okay, just imitate different function of human nose and human tongue, all right, and then assisted with the machine learning to make the decision process, decision making. And then we have dilate, okay, that's determined through the interaction of dielectric properties with electromagnetic energy. The fundamental equipment, similar like other techniques, it consists of a sensor, and then data processor. And this one is about acoustic, which relates to the relationship between frequency, resonance frequency, and the fruit property. So from there, by using the right data processor, we can discriminate, predict, or assess the quality of the fruit accordingly. Okay, now let's go to the case study. First one is backscattering imaging for fruit or vegetables quality detection. So it is based on the interaction between light to the fruit samples. Okay, in this case, papaya. Okay, as shown in this picture, it is papaya. Okay, so you can see here there is this is a camera. Okay, this is the laser light that's shown to the samples. You can see, you also can see here a small dots. Okay, this, when we acquire the image, when we capture the image, we can get these images. Okay, so you can see the difference here between image A and image B, which carries useful information about this fruit. All right, so basically, the backscattering imaging manipulate the interaction of light source to the sample tissue. Okay, we know that when light hits the fruit surface, it will be absorbed and then transmitted as well as reflected to the surface. So this behavior being studied and then manipulated in order to come. And then we manipulated this characteristic to come up with the internal information of the fruits. Okay, so how it works? All right, so for example, here we have 3 bananas at different ripening stage. We have ripening stage 2, ripening stage 4, and ripening stage 5. It's easy to identify ripening stage 2, right? Because the color is fully green. Okay, but what about this ripening stage 4 and 5? Okay, it looks almost similar. So how to segregate that? All right, so by using this backscattering imaging, we put the samples under the camera and then shine the lights. Okay, laser diode, very intense light. But don't worry, it's safe to be used because it's within the visible light, visible spectrum, and then very low energy. Okay, just less than 50 milliwatt. Okay, and then based on the condition of the fruit, we can and then we acquire the scattered light. Okay, reflect by the light. This is how the image processing being conducted, and then followed by data analysis. In the end, we can segregate the fruits accordingly based on its ripening stages. Okay, ripening stage 2, ripening stage 4, and ripening stage 5. So based on the image that we have processed, okay, it's clearly can be seen that there is a different in terms of size of the scattered light. All right, from ripening stage 2, 4, and 5. Okay, so the theory behind this, the mechanism behind this is, okay, so in this case, we use a 650 nanometer laser light, okay, laser diode. So we know that 650 nanometer is very closely related to the chlorophyll content. Okay, so ripening stage 2 has lots of chlorophyll. This is reflected by the green color of the fruits. And then compared to ripening stage 4 and 5, which have a lesser chlorophyll because of the appearance of carotenoids, which is reflected by more yellow than green. So we know that ripening stage 2 have more chlorophyll. So when we shine laser light at 650, of course, it absorbs more light. That's why we can see here only small size of scattered light compared to ripening stage 4 and ripening stage 5. Then we can classify the fruit according to ripening stages accordingly. Okay, so this technology have been tested to many conditions. Okay, this first case is chilling injury in bananas. Okay, in order to induce the chilling injury, we store the fruits in the cold storage, in the cold room, okay, at 6 degrees Celsius. and then we wait for the fruits to not waiting. We measure every day, or I think not every day, maybe 2 days, every 2 days. Okay, to monitor the appearance of chilling injury symptom. So chilling injury is one of the serious problem in fresh produce production, because the problem is it takes time to appear, and sometimes it appear immediately after being exposed to the ambient temperature, but sometimes it takes a very long time to appear. So it's very important to to find a early detection method. All right. So based on our study, we can classify the injured and non-injured fruit accordingly with misclassification error of less than 6%. And then these are another method for image analysis of backscattered light instead of using morphological features based on shape, like area, diameter, radius, and so on. So I try to use, fitting the intensity. I try to plotting the intensity level, and then fitting to the mathematical model. And then from here, we can identify inflection point, and then radius saturation. We also can find full width at half maximum, and then many other parameters that could be used to relate with the properties of the fruits. Okay, this is my favorite, okay, because I prefer to have seedless watermelon instead of seeded watermelons, because it's really disturbing when you eat something that have a seed inside, right? So I'm very happy to know that by scattering imaging able to classify, to detect which one is seeded and which one is seedless watermelon. And then it also able to predict the fruit properties such as firmness, soluble solid contents, pH, and moisture content. We also tested the capability of backscattering imaging to monitor the drying process. You know that drying process, it involves is very time and energy consumption. All right, so which later affect to the cost of production. Okay, so it's important to have a sensor to monitor the drying process. In this case, we try to use backscattering imaging, and based on these images, you can see how backscattering image related to the moisture content. Okay, you can see from fresh samples until to up to 4 hours, there is a significant difference in terms of the scattered light. All right. And then oil palm fruit bunches maturity. Okay, this is very important for oil palm industry, because they need to produce a good quality oil palm, good quality oil. Okay, so in order to get that, it must process FFB at the right ripening stage. Okay, so we test the capability of backscattering imaging to detect unripe, ripe, and overripe, and it's really can segregate these 3 ripening stages. And it resulted more excellent result when we combine with RGB imaging. So you can see here clearer separation between the samples of unripe, ripe, and overripe. Next, a case study about the usage of multispectral imaging. The concept is similar, of which we use the concept is similar, but this time we use a multispectral camera as a sensor, and then the process is also similar. We analyze, we use data processor, okay, use machine learning to analyze the image, and then come up with the decision making of chilling injured and non-chilling injured. And this one is thermal imaging for fruit and vegetables quality detection. You know, thermal imaging is very popular nowadays to detect COVID patients, persons that being infected by COVID. So we inspired with that technology. Okay, basically after several studies, we get to know how thermal imaging is one of excellent sensors for discriminate the fruit quality. So in this case, we try to use thermal imaging to detect several varieties of pineapples, and then quality, the change of quality when put in the storage, okay, at different storage temperatures. So the system, the components is just a simple component, thermal imaging camera, which is portable, and a computer for data processing. Okay, this is the methods how we come up with the prediction and classification model. A similar approach, first image acquisition using thermal imaging, and then collect reference parameters, quality parameters. Next is image processing, and then data analysis, which we come up with prediction and classification model. And the result shows that thermal imaging is proven can be used to predict the quality of pineapples at different varieties. Okay, here we have MD2, Josephine, and Maurice with R-squared value, promising R-squared value data. All right, and then it also can be used to classify the fruits accordingly into its storage temperature, storage days, as well as its varieties. And then thermal imaging also has been tested to detect maturity level of durians. Okay, in Malaysia, we just let the durian falls to the ground that indicate the fruits are already mature or already ripened. So, but some of the countries around, some of the producing countries, they pluck the fruits on the tree. So they need a sensor to to detect the ripeness level of the durian. Okay, so based on our study, it shows that thermal imaging can be used to segregate the durian ripeness level, okay, efficiently, as you can see here based on this PCA data. Sorry, PCA results. All right, then let's discuss about future prospect. So when talk about future prospect, I would like to recall when during my childhood, okay, I love to watch this movie called Back to the Futures. And at that time, I really admire how the director of the movie imagined about the future, the advancement of the future. At that time, we have, the producer thought that in the future, we have smartphone, smart monitor, okay, a touch screen monitor, and then we have a flying car. And then today, indeed, all the imaginary by the directors have been realized. Okay, who knows that someday we have that kind of advanced technology. So in future, perhaps our farmers, our agriculture, fresh produce producer, the food producer also can be like Iron Man probably, okay, just wearing a nice helmet, okay, like Iron Man, go to the farm and then do the scanning, and from there they can identify which plots is ready to be harvested, and then which plot needs to be watering, and then which plot needs to put more fertilizers and so on. I think we work with that.
I'm sorry, Dr. Sheila, you have around 2 minutes.
All right, okay. I almost at 2 p.m. Okay, 2 minutes, right? Okay, and then today we have this smart glass. Okay, this simple smart glass can identify the temperature around us. And then I think all of us start working on developing of this smart glass to be used, or smart goggles to be used for agriculture productivity. All right, that's all from me. Thank you very much. Terima kasih.
Okay, thank you very much, Dr. Sheila, for a nice presentation. Actually, now it is a little bit hot in Malang, so I am sweating a little bit. So thank you. We will get back to you later, Dr. Sheila, in the question and answer session. So it is a little bit hot here, but I guess in Japan, it is cold. Is it, Pak Anton? Hello, Pak Anton.
Yeah.
Konnichiwa.
Konnichiwa. Can you hear me?
Yes, yes, I could hear you very
Or
clear.
I need to use the
Air conditioner.
conditioner to heat up my room.
Okay, so the second speaker will be Pak Anton. So I will introduce Pak Anton a little bit to all of you. He graduated from Gajah Mada University in Food and Agriculture Technology study program, and he also graduated from Kagawa University in Graduate School of Agriculture, and currently he's working in Fuji Oil. Even though the name of the company is Fuji Oil, his research is about chocolate. He's doing many things about chocolate, so I think it is everyone favorite topics. So we are looking forward for your presentation, Pak Anton. So time and place is yours.
Okay, thank you for the introduction. First, I will try to share my presentation. Okay, can you see the presentation? Okay, first I would like to say thank you to Brawijaya University to inviting me as a guest speaker to share my experience, my knowledge I have got in Japan while working in Fuji Oil Company. So I will give this introduction since Mr. Dimas already introduced me. So here is our three subtopics. First, I would like to explain about the chocolate in general, then the market strength in Japan, and in the final, I will introduce the chocolate innovation in Japan. In every section, I will show you the market product to help us to understand more about the Japanese chocolate. So, what is chocolate? Chocolate, whether bar, coating, or ice coating, is a food made from cacao bean. Very simple. Powder material like sugar, milk powder, and any other ingredient are dispersed in fat and oil. Please remember it's not dissolved in the fat and oil like we dissolve sugar on the water. It's dispersed. So, powder material contribute to the chocolate taste and its viscosity, while fat and oil contribute to the physical properties like texture, melting profile, and crystallization rate. In Japan, any sources of vegetable fat and oil can be used in chocolate, but not in America, which chocolate is referred to pure chocolate without using any of vegetable oil and fat other than cocoa butter. But it's different in Europe. The use of vegetable oil and fat is permitted also, but limited to 5%. Generally, chocolate is grouped into sweet or dark, milk, and white chocolate. Sweet or dark chocolate it doesn't contain milk ingredient, while white chocolate doesn't contain cacao liquor or cacao mass or cocoa powder, and milk chocolate contains both of cacao liquor, cocoa powder, and milk ingredient. Based on the research done by Statista in 2019, 60 to 70% of the chocolate in the world refer to sweet or dark chocolate. 20 to 25 is milk chocolate, 5 and 10% is white chocolate. Based on the Chocolate and Cocoa Association in Japan, the chocolate product is divided into three categories: chocolate product 1, 2, and chocolate confectionery. Chocolate product 1 is a chocolate made from 100 chocolate dough, like chocolate bar or molded chocolate, without any combination of other food. chocolate product too, like Kit Kat, is the chocolate mixed or combined with other foods like waffle, biscuit, or cookies. And the chocolate dough is more than 60%. If the chocolate dough less than 60%, but still more than 20%, is categorized as chocolate confectionery, like Pocky product. This regulation is Japanese specific regulation to create a fair competition in the chocolate industry. Here I will explain about chocolate sensory property. Uh, it- it's cacao bean and powder material like fruit powder, tea, milk ingredient which contribute almost to the sensory profile of the chocolate. In chocolate and cacao industry, there are flavor beans and base beans of the cacao bean. Flavor beans have specific flavor like berry, fruity, floral, or citrus, depends on the origin of the cacao bean, while base beans have more intense and stronger cacao flavor. Here is an illustration of the cacao bean distribution in the world. In cacao industrial, there are basically three types of cacao beans. It's Criollo, Forastero, and Trinitario. But recently, there are some research who categorize cacao bean into more than 5 or 10 types based on the genetic information. The Criollo, known as the flavor bean, are mainly cultivated in Venezuela, Dominica, and Ecuador. The second one, Forastero, also known as the base bean, it contributes to almost 80 to 90% of the cacao bean in the cacao bean production in the world. It's mainly cultivated in Ivory Coast and Ghana. The last one, Trinitario, also known as a hybrid of the Forastero and Criollo type. But please remember this category or this classification is a common practice which is transferred from generation to generation in the cacao farming industry. So if you like buy Venezuela bean, there is no guarantee it's 100% Criollo bean. And also there is no any label information of cacao bean types on the chocolate product. Okay, the another one which contribute to the chocolate property is the another powder ingredient like this product. In Japan, it's the use of powder ingredient is permitted in the chocolate. And if the composition meet with the regulation, we also can put the product name on the label. For example, for strawberry chocolate, it should be the strawberry powder should be contain more than 5%. And Kokuto chocolate, Kokuto is brown sugar, so we can call it brown sugar chocolate if the brown sugar powder more than 2%, or cheese chocolate. And the last one is caramel chocolate, if the caramel powder composition more than 5%. Okay, the next is the physical properties of the chocolate. Physical properties like viscosity, melting profile, texture, and solidification rate are mainly affected by fat and oil and also its composition. Fat and oil play important role in Japanese chocolate since it has broadened the possibility of chocolate application with different character and properties. For example, bar chocolate, it should have heat resistant and anti-blooming character. For ice coating, it should have fast solidification rate and anti-cracking. And for filling, It should have smooth texture and crystal stable during the storage condition. Okay, the next one I will explain about chocolate market, the market trend in Japan. So in Japan, chocolate is the top for production in the 2020 and consumption is increasing from year to year. After 2014, the consumption reached 2 kg per person, but still very low compared to the Switzerland, German, and another European country, which is can reach 9 to 10 kilograms per year. But in Indonesia, the chocolate consumption is still very low. It's about 0.5 kilogram per person per year. Still very low compared to Japan. In Japan, the climate is not suitable for the cacao farming. Therefore, Japan import the cacao bean from the cacao producer country. 80% of the cacao bean used in Japan is imported in Ghana. Strong cacao taste, stable quality, low foreign material, price stable, and production is the four reasons why Ghana bean is very popular in Japanese chocolate industry. Even the top company in Japan, Lotte, the top number 2, they have Ghana branded product on their line product. Here I will explain about chocolate market trend in Japan. First is the focus on Japan origin or local ingredient like Uji matcha chocolate, Hokkaido cheese chocolate, and Sakura chocolate. Uji matcha. Uji matcha is the top 3 matcha in Japan other than Shizuoka and Sayama matcha. After tea was brought into Japan in 13th century, it was cultivated in North Kyoto and Uji. Since the climate is very suitable for growing tea. So we also can say Uji is like the origin farming area in Japan, which have very long history. The second one is Hokkaido cheese chocolate. Hokkaido is the number 1 milk production in Japan. It refers to 52% of all the production in Japan. The Hokkaido climate and its topography is very suitable for horse cattle and for milk production as well, which is also a good condition for cheese production. That's why cheese powder from Hokkaido is very popular in Japan. Sakura. Sakura is also another Japan origin item. In 2019, product with Sakura flavor is become trend at the time, included in chocolate industry as well. Many chocolate companies try to develop new chocolate product with the Sakura taste, but it's quite difficult since the material is very heat sensitive, very rare and expensive. For the petal powder, it costs more than 500,000 rupiah for 100 grams. So it's quite difficult to apply it in the industry. Second, market trend second is a standard product and limited product strategy. Generally, the top player company in Japan has standard product which is sold in the whole year and limited product edition which is only sold in a certain time or season or sometimes in a certain area. For example, the KitKat product. The fourth upper line is the standard product of the Nestle. with KitKat brand, and the below one is the limited edition of the KitKat brand. For example, this one is the KitKat product with Sakura and Sake flavor. This one is orange KitKat, which is only sold in Tokushima, Kagawa, Hiroshima, and Ehime area. This one is apple pie KitKat, Sakura Mochi KitKat, Mango KitKat. Mango KitKat is a special product which is only sold in the summer. And this one is Purple Yam KitKat. Purple Yam is one of the famous agriculture products in Okinawa. That's why this product is only sold in Okinawa and Kyushu area. This one is Sakura and Posted soy flavor KitKat. And this one is salt and lemon KitKat, which is only sold in the summer area also. This product use the seto sea salt, which is one of the famous salt in Japan. Cheesecake KitKat, Shinshu apple KitKat. Shinshu apple is one of the variation of the Japanese apple, which is very famous in Nagano Prefecture. Mint KitKat chocolate, which only sold in summer area, and the last one is Kobe pudding chocolate, which is only sold in the Kobe area, since Kobe is very famous with the pudding. The third one is the environment concern strategy. Recently, in Japan, the concerns about the environment concern is greatly increasing. Almost every top player, top chocolate player, chocolate company in Japan have their own sustainability program. For example, Meiji, they have agroforestry project in North Brazil, in Pará. They have cooperated with the local farmer and established cacao farming while growing the forest as well. The cacao harvested from the farm are used to create this milk chocolate called Meiji Agroforestry milk chocolate, which is have four packaging types. The first one, it shows the first step when they start to growing the cacao fruit. The second one, it shows the cacao start to bear the fruit and can be harvested, but it's not in the maximal yield. And the third one, this one, it shows the cacao growing well as well as the another plant, which is broaden the forest condition as well. And the last one is the last step where they can harvest the cacao at the final at the maximal yield, as well as the another plant also can be harvested as well, like avocado or palm tree. The another project is from Nestle. So Nestle have project, they change the outer plastic packaging of the KitKat product to paper packaging. With this project, they already reduced 380 tons plastic waste per year. Okay, from this, I will explain and introduce the chocolate innovation and trend in Japan. Here is an illustration of the chocolate trend transition in Japan. So around 1919, it's also called a patisserie generation. In this area, a lot of the young Japanese people, the young Japanese, went to France and your country to learn about Western sweets, then come back to Japan to open shop and create their own brand product. And it's not only happen on chocolate, but also for the cake and food gourmet uh, industry. After 1990, high cacao becomes booming. The more cacao content, the more precious the product becomes. At this time, consumers start to concern about the healthy. It's also supported that many research show the polyphenol content in cacao also have antioxidant activity, which can prevent aging and also have anti-cholesterol activity. That's why the consumption, the need of the high cocoa also increasing on that area. After high cacao area, the manufacturing uh, start to research about the cacao bean from different origin, and it shows the cacao bean from the different origin also have different polyphenol content, and also depends on the fermentation process also. At this time, manufacturers take this opportunity to develop and introduce the single bean origin chocolate. Uh, for example, like Brazil origin or Cote Ivory origin.
Anton sumimasen. You
Yeah.
4 minutes left for your presentation.
Oh, okay. Sorry. And the next one is bean to bar and healthy chocolate. The healthy chocolate, I will explain in the next slide. So healthy chocolate like low sugar, which is sugar content is less than 0.5 gram for the 100 gram chocolate. It use sugar alcohol like maltitol and erythritol as sucrose substitute. And the below one is lactic acid bacteria chocolate from Lotte. It's claimed that the product has more than 100 times as much as sulfite bacteria after reach the intestine compared to the conventional yogurt. Okay, this is the healthy awareness product again. The high content, which is also popular for the senior above 50 years old and the woman also. And the below one is GABA of fiber formulated product. GABA is gamma aminobutyric acid, which is also present in the human brain. In medical research, GABA works on brain nerve and play important role to give relaxed feeling. The product claims it can reduce stress and also help to improve our sleep quality. Okay, here is the Japan origin product. I already explained on the previous slide. So, especially for this topic, this is like never-ending development. Science is also related to the local cuisine promotion as well. And the next one is the value or function upgrade. Different with the Magnum, which is very popular to the Europe, Indonesian, and almost Southeast Asian products, which is have hard and crispy texture. In Japan, Palm is more popular than than Magnum product since it has smooth, soft, and smooth texture. The fat and oil modifications like esterification and also the cooling technology modification have enabled this product become available in the market. And the last one is the current trending pistachio. A lot of products from bar, filling, ice coating, and sandwich already the profit on this year in terms of this pistachio. And the another one is also plant-based product. A lot of Japanese companies try to make plant-based chocolate, which is can substitute the milk chocolate. Okay, that's all of my presentation, and here is my message for all of you that agriculture products have unlimited potential. It just needs you and us to discover and maximize the potential, and the technology modification will play important key in this process. Okay, that's all. Thank you.
Thank you very much, Pak Anton. Very interesting presentation. Maybe after this, I will go to mini market and buy some chocolate. Okay. Okay. I will introduce all of you. I will get back to you, Pak Anton, later in the question and answer session. So now I will introduce everyone to the third speaker. He is Dr. Daniel. Actually, I would like to congratulate Dr. Daniel. He just graduated maybe several weeks ago. So he got his bachelor degree from Universitas Brawijaya, master degree in Kyoto University, and Doctor of Science from University of Foggia, Italy. So
Are you done copying?
Hello, Daniel, Dr. Daniel.
Hello, Mas Dimas. Hello, Dr. Dimas Firbanda. Yeah.
Buongiorno.
Buongiorno. Buongiornata.
Buongiorno. So I think it is in the morning in Italy, right?
Yeah, this is early morning at 10 o'clock. 10:19.
Okay. It's afternoon here, so
It's very cold here. It's now still winter and
yes.
windy.
Nice. Very hot here now. So
I can see you are sweating.
I'm sorry. Okay, we don't want to wait for more.
Maybe
so
I can hear a noise here. Maybe someone has to mute the microphone. I don't know. Like
check.
Yeah.
Okay, maybe everything is good now.
Okay, everything is good. Yeah, thanks.
Okay, please, Dr. Daniel.
So, can you guys look at my screen? Everything okay?
It's
do I
great.
have to- Okay. Nice then. Okay, good morning, everyone, or good afternoon, everyone. Thank you for the chance. I would like to say thank you especially for Mas Dimas, who invited me for this webinar. And here I would like to introduce myself and what I'm doing and what we have done and about our activities here. Well, here I'm going to talk about business and business opportunities in post-harvest. And especially I would like to talk about my my company. Like, well, I am with some associates and I'm one of the co-founder. And we actually incorporated like last year, supported by EIT Food in European Union, and we are funded on 2020 actually. And the research was conducted on 2018. So it took us 4 years to establish the company. Well, what is actually our objective here, which is a post-harvest technology extending the shelf life of fresh fish by 3 to 4 times compared to conventional method. Well, I believe everyone here already understand, already famous, or already familiar with model business canvas. So this is like an example, the importance of building up a business. We have to understand the skeletons which are necessary to conduct our business. Well, here you can see that we have problem and we have to identify solution, our unique value proposition, unfair advantage, and etc., including our partner and all the other important skeletons. Then after we build up our business model canvas, we can expand to the muscles. Well, I will not be so long here because you guys will have these PowerPoints and you will see the example of model business canvas, how to have your own business, your own startup. I'm going to explain about our BMC, which is firstly is problem. what is the problem we identified here? As you may know that actually this is like a kind of global problems that our ocean maximum capacity already reached by 2018, and we are now 2022. We are now in 2022 shifting our fish production into aquaculture as our industry supply shift. And this is the European fisheries outlook. Look, in the European Union, we already reaching our maximum capacity of production, which is only fulfilling 40% of self-sufficiency. And look, this is about 5.5 million, around 40%, but ironically, we waste 2 million tons of production every year. So this is kind of a problem that we have to solve. And it is reported that loss and waste are caused by inadequate process and hygiene. How come? Why do we have this? I will tell you better. Well, the existing solution nowadays, you can see also, I think in Indonesia, especially we have a lot frozen storage products from fish. Well, it has the advantage of long shelf life of up to 1 year. However, it is poor of quality, and you may have the difference of taste, which is tasteless and low of nutrition. And secondly, we have ice cold storage. Well, if you go to the supermarket, maybe in Malang we have Matos or Hypercube. I don't know if you have Hypercube. I'm not sure. Well, in the market, usually you see this kind of presentation. Fish products on pile of ice, and these lead to the lowest shelf life of up to 5 days. Well, this has also disadvantages, which are contamination, weight loss, because of the different temperatures, so they evaporate the weight. And of course, in industry, this is kind of economical loss and contribute to the food waste. The next is passive map. What is passive map? I think you already understand because I believe your background are in agriculture, engineering and agriculture technology. So the passive map is just actually simply you wrap and you package the products with plastic or some other barriers. And also vacuum packaging. This is the technology is just to have a vacuum composition of packaging by additional sealer. And of course, it has very short shelf life still, up to 12 days. And here is our company solution, actually, the post-harvest technology that maintains the sensory quality, nutritional quality, and increases the shelf life by 3 to 4 times. And this is our main productions. Actually, this is sea bream that we can improve the shelf life up to 40 days under 4 degrees Celsius, and also sea bass up to 30 days and 21 days for shrimps. They are all fresh products. And what is our technology description? Maybe you may imitate or develop based on the needs in your place. And we actually develop our technology by the help of University of Foggia and some project, which is first is computer vision system. We are grading the quality of our stream product, our after harvest. And then we use some technique, which is pathogen counts reduction by using UVC radiation, which is already well known actually. And we coat our fish by using gamma aminobutyric acid. This is kind of antioxidant. And we use also active packaging. Well, the purpose of active packaging here is just to reduce the growth of microbial counts, pathogens in our products. And the storage, this is also very important aspect in the post-harvest technology, where we have to find the appropriate storage conditions for our produce. And usually for higher cold storage that we have is around 4 to 5 in our kitchen, in our home. And this is our technology adoption. And you may know that the customers, we have to identify who are our customers. And in this case, we identified our customers from B2B, which is business to business, or maybe you might heard about B2B2C, where or only B2C, C meaning that the end consumers. So here we identified our competitor here in European Union. We have our competitor with a shelf life of up to 12 days, and our company can improve the shelf life up to 40 days. And about the fresh weight loss of our product, where the competitor only reducing or decrease the loss of up to 20%, and here we have the reduction of only 2.5% of our products. And about the European fish waste, so by utilizing, we proposed this already and we got the project, and we have the reduction of waste of up to 1,200% in the European Union fish waste. What is our secondary benefit of extending shelf life, providing availability of reaching new markets? So we have here the European map, where you see in 2 days, we can just reach local consumption only, local consumers. But within 10 days, we can reach in the country. And in the month, or within a month, we can reach most of neighboring countries. But in 40 days, we can reach all of European Union countries. What are the market size? So usually before you build your business, you have to understand your market size. So who are your markets? What are they? So here we identified, firstly, we want to, we focus on Italy and Greece. This is our, in the yellow circle. And what are they? They are fishery units, so the packaging unit, or even aquacultures. So we identified there are 1,709 units, and this is our markets. And Greece representing the higher markets, because you may know that Greece is just like Indonesia. They have a lot of islands and they have big fishery products. And what is the business model? In the business model here, you have to understand what are your revenues streams. So for example, I give you one example of our revenue streams here. We have sales of equipment, so we build equipment, and then sales of consumables, which is films, gas mixers, which is active map, and coating line. We have a coating line. We coat our products. And services provisions, which is installation. If the customers buy our product, we have the installation cost, and also we have clients' personal training, and we have also annual maintenance. And this is the revenue that actually in a new company, we have to have a projection also in the within 5 years at least to understand how the business will work. So, okay, I will not talk about this much. And about the financial, for example, if you have to your revenue, you will understand how much turnover breakdown you have. So for example, cost of the goods sold, operating expenses, tax, and net income. We have our 3 new customers from Lidl. Lidl is kind of, what I can say in Indonesia, kind of 7-Eleven and Indomart that are using our technology. So this is our main customers right now in Greece and in Italy. Okay, we have to identify also the impacts. What are the impacts of our innovation? So here we identify we have a good health and well-being from the United Nations, and also mainly responsible production and consumption and the food loss. This is our colleagues, actually, another company supported by IT Food European Unions. Actually, the idea is very interesting. So this is actually not really scientific, but they know how to manage the things. So they have identified in the market people or a producer are substituting the high value market fish with the lower one. For example, here, this is actually some kind of squid, but people tell this as octopus. So they are actually very different products with a very different price in the market. So this fraud is identified by this company. So this company identified, they make a label and some kind of BP POM, if we have it in Indonesia, some certification for food safety. So their idea is just the same. Actually, we have also EFSA in the European Union, but they are government, and this company is private, which is more trusted and regular for the inspection, because they have the barcoding, which is DNA barcoding. Actually, they don't have the lab, and they outsource the lab. So what does outsource mean? They collaborate with the laboratories within European unions. And for example, if you may know that we are only 40% self-sufficiency and 60% are purchased from the other continents. So there are so many international trades here, and this company is very well productive and very well and earning very well in European Union right now, and they are my colleagues. So maybe you can have the same idea, establishing the same thing in Indonesia. So their motto is if you pay for premium, you must get the premium, and this is about the customers' awareness. If you pay more, you have to get higher quality. And another business aspect, which is maybe becoming so booming right now, maybe not yet in Indonesia, but you may think about it in the future, because the trend right now is always increasing, which is fresh cut fruit and vegetables. Based on the data in the European Union itself in 2017, all ready-to-eat, all households are now consuming ready-to-eat fresh cut and vegetables. So more than 70% of households. And the sale increased 4.8% in volume and 5.2% in value. And you can see here the salad trays and vegetable snacks increased 43%. So maybe this is becoming a good idea or business idea in your place. You may have this kind of product by using your local producers, and you serve the customers with ready-to-eat vegetables and fruits. Okay, this is kind of a little bit technology why you are more than the common sellers. So because we are all from agricultural technology background, we may use a little bit technology to have a different quality of products. So for example, we are here using the gas composition EVAC. So this is talking about modified atmosphere packaging or controlled atmosphere storage. You may see here is brassicas. This is called, we call it chimney di rapa, which is kind of broccoli or spinach, maybe. Just some kind of the similar kind of products. So by using 3% of oxygen composition inside of the packaging, we can store up to 14 days at 5 degrees Celsius. You may see the difference. Air is just in the air storage, and in the 3% of oxygen you may see here, look very fresh and green. And the second thing, if your product has browning, you may use anti-browning treatment. So here I give you example of artichokes, which is using cysteine kind of amino acid as the anti-browning treatment before packaging. So we can store up to 5 days storage in 5 Celsius before the expiry date. Another thing is, the titanium oxide. So you see here, the titanium oxide can reduce the browning of eggplants, sliced eggplants. So in 12 days, you can see here, in 5 degrees Celsius, they are still white, and in 5 days, you can see the difference. Another thing, if you have your microwave at home, you can have your own experiment. So here about carrots. So if you treat your carrots up to 7 with some level of power with your microwave, you can have the different effect after you store it up to 7 days. So here is the microwave 0, meaning that initial, and control. So the control itself, they have color reduction and quality. But by using some different kind of power, you maintain the quality of carrots itself. You may see the different color here. And another interesting thing is the use of probiotic riboflavin over producing lab strains as valuable strategy to improve the quality of fresh cut produce. So the idea here is to put probiotic in your products, so you can claim the increase of value from your products, as well as the quality of fresh cut itself. So you will prolong the shelf life by adding some probiotic in your produce. That I think this is an interesting idea to be applied in your place. And another thing is essential oils. You may try many other kind of essential oils. And if you browse in Google Scholar, there are so many publications on essential oil, on the quality of produce. And this is a bit more advanced maybe, but the application is actually very applicative, where from the previous speaker mentioned about fluorescent technology. So why this is interesting, because fluorescence is using visible camera, which is very cheap. You may produce your own product, your own tools to identify the quality of produce. So for example, here is mature and immature green tomatoes can be identified by using simple fluorescence. This is the presentation of my professor about a research that I conducted on goji berries. So by using different temperatures, we have prolonged the shelf life of goji berries. For example, goji virus is a berry which is very easy to deteriorate. So only for 2 days, usually already rot. And we can extend by using different temperature storage, where here we found that 5 degrees Celsius is the best storage. And another thing is strawberry. So strawberry itself, there are 2 different conditions of gas composition. Area is air, and 20% of carbon dioxide can improve the quality of goji berry and improve the shelf life of up to 4 days. And this is about goji berry again, on using different composition of gas, where we found 20% of CO2 composition can maintain the shelf life of goji berry of up to 22 days. Here, sorry for the Italian, but this is 22. This is a local TV, Italian TV, so he represented in Italian TV. And 22 days is the shelf life. So from 3 days up to 22 days. Okay, another thing, this is maybe the different looks, appearance of the berry itself. Here is the control, and this is the modified atmosphere fruits. Another thing is grapes. So here we found that 10% grapes, 10% CO2 grapes can have the best quality up to 27 days. So if you compare to control, they have already fungi. This is mold, botrytis mold, and in 10% CO2, you can maintain the quality without the infection. While here you can see the infection still, but here is the optimum condition.
I'm sorry,
Okay.
Dr. Daniel, 3 minutes left.
Okay,
2 minutes. 2 minutes.
Okay, 2 minutes left. Okay, well, the next interesting thing is microgreens. Maybe you may know that microgreens is different from adult greens, adult vegetables that we consume usually in the market. Here is the benefit is we have the very short day production, so very rapid production with a higher nutritional composition compared to the adult one. So if you may use this one in your salads or soups or pizza or even your juice or smoothie, so you might think of products by using microgreens, or even you can develop microgreens at your home for the production, and you provide microgreens for consumers. And about funding here, this is maybe interesting thing. I'm talking about European funding, and I think Indonesia is also eligible country to participate in the funding itself. So we have latest statistic last year. We have 56 projects chosen with 160 million total funding distributed. And this is the statistic, around 45% higher education, like university, 24 private companies, and 28 research organizations, and 3% others. What can they offer here? If you have the idea only, they will provide you 4 billion euro. And if you already have research established, you can start or improve to market up to 2.5 million euro support. And if you already at the market level 9, which is ready to market, they can support you 15 million euro. Okay, maybe this is my group in the lab. So we are in Foja, and these people are our group, and this is our activity, and this is the recent funding that we got. Thank you. I hope it is not that fast.
Thank you
It is
so
not
much.
fast.
Thank you so much for interesting presentation, Dr. Daniel. So we are now in the question and answer session. I would like to give a chance for any participant who want to ask directly. Is there anyone who want to ask directly? You could raise your hand. Don't worry, you also can. Okay. Okay, Bu Elia, please.
Okay, thank you, Dr. Dimas. Thank you for opportunity for me. I would like to ask to Mr. Anton. When we are in Japan, we often confirm whether the added fat used in chocolate product is animal or plant. So, what is the difference in the quality of chocolate products if they are added with animal fat or plant fat? Maybe any other companies consider using animal fat or plant fat. I think it's enough. My question. Thank you.
Thank you, Bu Elia. Please, Pak Anton.
Okay. Thank you, Bu Elia. Should I call Bu Elia? Okay. Thank you for the question. First, basically, the fat and oil used in the chocolate product is from vegetable, and oil is not from animal fat, except for the butter oil. Which is only one from the animal fat it could be used in the chocolate product because it can enhance the flavor taste. So almost the chocolate product, why it use the vegetable fat and oil because of the properties of the vegetable fat and oil. It's much more easier to modify the vegetable fat and oil with the like esterification processing, hydrogenation processing, and also from the economical value and also from the sustainability. So it's much more to have sustainable value from the vegetable. It answered both the question.
Okay, thank you for the answer, Mr. Anton.
Thank you.
Okay, thank you, Bu Elia and Pak Anton for the question and answer for nice discussion. So there is one more participant who would like to ask directly. Please, Pak Luki Tawesa.
Hi, thank you for your time. I would like to ask for the first presenter, Dr. Nur Hasila. My question is, how far are we in the machine learning, especially in the post-harvest, in effort to avoid fungal contamination, for example, in onions? Because here in Europe, most of, especially in Scandinavia, where I live now, most of the onions are imported from another country, and then they are not necessarily fresh onion, but they are usually like has been stored for 1 year or 2 year in a silo. And I found that in a period of several months, a lot of the onions are contaminated with Aspergillus niger, for example, that has a greenish color spores, and that makes the shelf life of onions is bad. But how far the machine learning and the sensor technology to detect the fungal spores, for example, that is contaminated in the agricultural product. Thank you.
Okay, please, Dr. Sheila.
Thank you for the questions. Lukita Wesa, is that your name?
Yes, you can call me Luki.
Okay, Lukit. Hi, Lukit.
Hi.
All right. So maybe it's related to me as well as Dr. Daniel. Maybe Dr. Daniel could invent something related to prolong the shelf life of the onions, and then I work on something on using sensors to detect the quality of the onions. All right. So I think there are many available sensors that could be used to detect the quality of, because the most important thing, we study the characteristic of the samples of the product that we intend to assess the quality. And then the first one about how far the technology have been used, the technology sensors being used, is that for industry or what?
Yes, for industry. Yeah.
For industry, it's very difficult to answer that because nowadays we study about the precision. We talk about precision agriculture, and then we convince people how it's efficient to assist human workers to make the decision making and so on. But I can say is the problem is still the number of industries adopt the system maybe is not at the right part yet. Maybe because of there are many factors contribute to these utilizations, but I'm pretty sure with by the time and then with the revolutions of the technology, and then when many people really aware about that, and someday with the economic and many factors that may contribute the usage of that sensors in the future. And then in terms of study, I think there are many available techniques, and then you give me ideas next project probably to study about this.
Okay.
Yeah, please for the audience.
Okay, thank you for nice discussion. Maybe
Yeah, because we import Malaysia, we import onions from India. We also import onions from other countries.
Maybe Dr. Daniel have some information about this.
Yes. Actually, we have done some experiments about onion. So usually, like the fungal defects is coming from botrytis infection, and actually, of course, like fluorescence can identify very easily this fungal infection. So if you might have there are publication actually, and if to maintain the quality itself, we tried some application of ozone for the washing, let's say, to reduce the fungal development. And after ozone, we use modified atmosphere packaging. So we have some result on that, and we are writing the result. And of course, MAP can improve, so improve the shelf life. Yeah.
Okay, thank you for a nice discussion, Pak Luki, Dr. Daniel, and Dr. Sheila. We have one more participant. It is Pak Marcel from Machung. I know Pak Marcel. So please,
Hello,
Pak Marcel.
Dr. Dimas. I'm already moved to Mondelez International actually.
Oh, I'm sorry.
To industry, from university back to industry again.
I see.
Yeah.
Okay, please.
My question is to Dr. Nur Shahila. Yeah, your presentation is very beautiful from my, because I also my research is also about precision agriculture, but the problem is all the technology that you mentioned is quite expensive. Is it difficult for farmer, especially in Indonesia, to access the technology? Is it possible to produce that kind of technology but at lower cost? How do you think about this?
Thank you, Dr. Marcel, for your questions.
I'm still master, not doctor. Doctor.
Soon to be.
Amen.
Soon.
Thank you, Marcel, for the questions. Yes, the problem is, we how to say, we suggest advanced technology, but whether the farmers afford or not to use that technology for their productivity. Yeah, I understand that, as especially for the imaging system, it's quite expensive. And then in order, I think by the time, the price could be reduced in future, because smart modern agriculture, precision agriculture nowadays. And then the other one is to choose the right imaging system, depending based on what we want, our intention, to what we want to monitor, what we want to measure. Okay, for example, if you just want to measure the freshness of cabbage, for example, it's just the price of cabbage is just I can say inexpensive. Okay, so is it worth that we use hyperspectral imaging, which the price is about maybe $100, I don't know, okay. So maybe for that simple assessment, just for the freshness, maybe we can use a simple imaging system. In fact, simple RGB camera is enough to identify the quality of the freshness of the cabbage. And then, in fact, nowadays, I think many researchers start develop a simple apps in the mobile phone. Okay, just using RGB camera from the phone to detect to identify something from including agriculture product. And the most important thing is, as I said earlier, what our intention, the thing that we want to measure, and then relate with the sensors that's suitable for that. I understand that the more expensive, we always hear that the most expensive one, the sensors could be. Not necessarily, but sometimes when we know that the gist that's the most the traits that we want to measure, and then when we focus on that, we just select the good maybe that imaging system related to wavelength, and then we select the right wavelength. For example, like backscattering imaging system, just use one wavelength. It's cheap system. Maybe that's enough to detect how to say, to use that smart precision agriculture for your productivity, for your production.
Thank you, Dr. Nur Shahila, for the answer.
Most welcome.
Okay, thank you for interesting discussion. Actually, we are in Universitas Brawijaya also working on that, Pak Marcel. So we are trying to develop system that is cheaper. Of course, if I may add some discussion here, of course, the material science is the key actually. For example, currently the NIR spectroscopy system is very expensive because of the sensor, in-gas sensors is very expensive. But recently, last December, one company launched a quantum dot-based sensor. That quantum dot-based sensor. So the price is 1%, 1% of the in-gas sensor camera. So maybe later, and I think technology also will be cheaper and cheaper. Also, currently, for example, I want to purchase some very good quality LED. The price is quite expensive, around $5,000 US. But maybe in the later in the future also, if the material science have developed so much, so all of them will be more cheaper, and we could design cheaper technology that will be that could be used by farmer. We are working on that.
Yeah, I want to visit your lab, Dr. Dimas.
Okay. If you are still in Malang, you can visit. I also want to visit your lab actually. Okay. Yeah. I would like to go to Malaysia, to UPM, to Japan again, and also to Italy to meet Daniel, of course.
You're most welcome.
Maybe after pandemic go away.
Exactly. I hope so.
Okay, everyone.
Daniel should invite us.
Yes, Prof. Imam. Daniel should invite us also to Italy. Okay, I would like to thank everyone, all of the participants, speakers, and for the nice discussion. There are many interesting knowledge that we got today, and I expect for further collaboration between our university and your institution. For Dr. Hasila, Dr. Daniel, and also Pak Anton, we hope for collaboration in the future. So thank you very much, everyone. We hope to see you again on the next webinar. Wassalamualaikum warahmatullahi wabarakatuh. Good afternoon and good morning, maybe in Italy. See you again. I will give back the time to the MC.
Thank you so much for preparing us for the lecture. So thank you so much for Dr. Hashim, Mr. Anand Pawiro, and Dr. Daniel Faturrahman for such an amazing lecture. It's such an eye-opening discussion from all of you. So, ladies and gentlemen, we are almost at the end of the event, and the last agenda is going to be closing. I'd like to thank you for all of our speakers and also for all of the participants. Hopefully, everything that we can get discussed and also could give some benefits into our environment. And also, we hope that in this pandemic of COVID-19, we won't stop us to always learning and sharing of our knowledge. I'd like to apologize for my mistake while being the host of this event. Assalamualaikum warahmatullahi wabarakatuh. Thank you, and see you in the next webinar session.
Thank you very much, everyone. Bye bye.
Thank
See you
you.
again.
Thank you.
Dr. Sheila, Dr. Daniel, Pak
Bye, sir.
Anton, Pak
Dr.
Marcel.
Daniel, thank you.
Mute, still mute.
Masih mute, Daniel.
Thank you, Prahibab. Thank you. Thank you for.
And then, Pak Dimas, next time Daniel should invite us to go there
Yes, that is for
and visit
sure.
some anything there,
Pak Dimas,
That
especially
is compulsory. Yes,
business.
Pak Marcel.
kebetulan kan
Marcel.
saya sudah pindah ke industri nih Pak, dan
Oh,
biasanya
iya.
kan ada kerjasama industri akademisi nih Pak. Boleh
Wah,
Pak?
ini ada
main-main.
Pak Dekan juga, Pak Marcel. Jadi bisa disampaikan nanti mungkin bisa, saya punya kontaknya Pak Marcel tetap ya.
Masih
Nanti
tetap Pak,
mungkin
masih tetap Pak. Baik
Bisa
Pak.
saya chat nanti.
Boleh,
Baik,
Pak
Pak.
Marcel. Nanti Pak Dimas, Pak, difasilitasi Pak Dimas.
Siap Prof, siap Prof. Terima kasih banyak Prof. Ya.
Oke.
Baik, izin live ya Bapak-bapak sekalian.
Oke,
Bapak-bapak
terima
dan
kasih
Ibu.
semua.
Selamat sore.
Recording stopped.
Oke, terima kasih. Bisa
Oke.
diakhiri.
Thank
Saya
you.
end ya semua. Terima kasih.